Right, good evening, everyone. So it's past 19:05. We can start our tutorial. Okay, as earlier indicated, today we're going to look at logarithmic functions. And we're just going to look at some questions, how to solve logarithmic functions. We're not going to go into much of the details. So let's begin. We have some questions here. So these are basic logarithmic functions here. So you have the first one. The first question here is asking you to simplify. We have two questions. There's log 81 to the base 9. We have log 1/25 to the base 5. Then we also have log 9 to the base 2, log 21 to the base 2 minus log 7 to the base 2. So let's start with the first one there. So for the first one, we have that we are given this log 81 to the base 9. You know, rewriting this, we can say, okay, this one is equal to that. Then this one, you can express it as 9 squared. Then using the rules of logarithms here, you know, when you have a logarithm, say log, say a b, then x squared, then this can be written as 2 log b x. So using this one here, so that is one law of logarithms. Using that here, you're going to see that this will give you, the 2 can come there. You have a 2 there. Then you have 9 there. Then you see from here, there is another law of logarithms there. When you have log 9 to the base 9, when these are similar, they are the same, this becomes a 1. So this one is equal to 2 times 1, which is equal to 2. And you're done. So for the second one, we have that we are given log 5, then 1/25. So, you know, this one here, you can work around with this to try and see similar, to make the base similar to this value here. So you say this one, that one will be equal to log 5, then 1/25 can be written as 5 squared. Then this in turn is equal to log 5 to the power -2 to the base 5. Then this will give you, the -2 would go there. You have -2 log 5. Then this will give you, this is a 1. This will give you -2. You're done there. Okay, so let's look at this question for the first one. So we have log 9 to the base 2 plus log 21 to the base 2. Then you have minus log 7 to the base 2. So we are asked to simplify this. How are we going to go about this? So we see, we notice the bases are the same. In this expression, the base is the same as that expression, even in that expression. So using the rules of logarithms, you see, you can factor out the log of base 2, say log 2. Then what will happen to these numbers is, when you have a plus here and the bases are common, you multiply this. So you have 9 by 21. Then when you have a minus, you divide. So you have divide by 7 there. And then you're going to have log 2. So you have that 21 divided by 7. You're going to get a 3. And then 3 times that one there, you see you get a 27. Okay, let us simplify this. So we're going to see that this one is in turn equal to, so you can express this one as an exponent. You're going to have 3 to the power 3. And then this power can go there to get 3 log 3 to the base 2. And then you've simplified. So that's how you simplify logarithmic expressions when given a logarithmic expression to simplify. Right. Okay. So let's look at our next question. So we have the next question here. Wait, before you do this one, let us do this one here. So we have this question here. This one is saying, write down ln of 8 times the 4th root of 5 in terms of, we have in terms of ln 2, then ln 3 and ln 5. So for this particular one, we're going to say, let us look at the solution. So in this one, you have ln of 8 by the 4th root of 5, then a lot of this divided by 81. All right. So, using the rules of logarithms here, you see you have 8 times this one, then divide by this one. By rules of the logarithms, you're going to say this is equal to the ln of 8 plus the ln of the 4th root of 5. Then you have minus, since we are dividing here, ln of 81 there. So we are being asked to express this expression in terms of ln 2, ln 3, and ln 5. So somewhere in this expression, you have to see ln 2, ln 5, and ln 3. Okay, so what are we going to have here? So you know that this one here, ln, you can write it as 2, 8 is to the power 3, then you have plus, then this you can rewrite it as 5 to the power 1 over 4. Then this one, then so 81 can be written as, first of all, you have that 9 squared is 81. Then this one is 3 squared, which is 3 to the power 4 there. So this one you get 3 to the power 4. Then again, you apply the rules of logarithms there to get, you have, so this one can come there, you have 3 in 2 plus, this one can go there, 1 over 4 in 5. Then this one here can go there, and you're going to get minus 4 in 3. And you're done, because you have ln 2, ln 5, and ln of 3 there as required. No stress.
Sorry, sir, I have a question.
Yes, please.
It's just for clarification. Is how do you pronounce that? L-I-N.
It's ln, but I'm pronouncing it as ln. It's ln.
Okay, yes. Ln. Is ln the same as logarithms, or maybe it follows the
Yeah,
properties of logarithms?
it's a natural logarithm. This is, and that is log. When it has the base e, say log ex, that's where it's been x.
Okay.
So it's just a logarithm. It's a natural logarithm.
Okay, thank you.
Yes, you can pronounce it in your own way. I pronounce it as ln or lin. Yeah. Okay, so let's look at our next question. Okay, I don't know if we should look at this. Okay. We're going to get back there. So we have a question on board here. Find the possible values of, so we have a simultaneous equation here. You have xy is equal to 64. Then you have log xy, log y to the base x, and log x to the base y being equal to 5 over 2. So here it's find the values of x and y. Solution. So let's start. So here, I can advise we start with this one here, because if you make your something like, you start with this one and try to make any variable there as subject of the formula, it's going to be ambiguous there. So let's begin with this one here. So you can take you have log y to the base x plus log x to the base y, this being equal to 5 over 2. So guys, here you do not no harm if you multiply out 2 to get, you have 2 log y to the base x plus 2 log x to the base y, this being equal to 5. So you notice there's a difference in bases. So you try to convert one base to a base that is going to be similar to the other one. So how do you do that? So you have a rule as well here. So let us try to convert this one. So you have that 2 log y, then plus, then this one you can change the base as. So we want to change it to base x. So you're going to say, okay, this is log x. You introduce the new base, then you maintain the x there. Then this divided by the logarithm of the base maintained, then your y will come there. So you've changed the base from y to base x, but this is equal to 5. What do we know when this is log x to the base x? So you know this is a 1. So you have 2 log y base x plus 2 over log y to the base x, this being equal to 5. All right, then there you see you can multiply throughout by log y base x to get 2 log y to the base x squared. Then you have a plus 2 there. This will be equal to 5 log this one. Nice and slow, nice and slow. All right, so this one you see that, okay, this is 2 log squared. I don't want to bring this power here. Then you have this one when it comes here, you say this is minus, yes?
Can you please kindly run through the previous step? I'm a bit behind.
Which step?
The part where you square the log x of y.
Oh, the log x of y.
Yes.
Right. Just okay. You're saying where we squared this one here.
Yes.
So what has happened? Yes, so what has happened here is, let me use a separate paper. Okay. So what is happening here is, here, you find the common denominator here. See? But before that, you try to make this one look like an equation. So you say this is 2 log x y plus 2 over log x y. Then this one will be minus 5, then being equal to 0, isn't it? Then you are going to say, okay, here, I don't want to see a fraction here. Yes, so I'm going to say, okay, the common denominator is that one. See? So you have 1 there. This is log y to the base x. Then this times that one. You see, this is similar. It is the same as multiplying x by x. You get x squared. So when you multiply this by this, you get log x y squared. Then this one is 1. This one will go there 1 time, times 2, you get plus 2. Then this is over 1 there. So 1 into there, you get minus 5 times this one. Then this is equal to 0. Then when you cross multiply there, you see you are going to come here. So but here, so that will be, so this one has come this side, you have minus log xy, then you have plus 2, and this is being equal to 0. And that is what we have here. So when you cross multiply, this one will go there to be a 0. Then you remain with 2 log y to the base x squared minus 5 log xy, then plus 2. So that should give you a 0. I don't know if that's clear.
It's very clear. Thank you very much, sir.
Yes, but again here, you know what one thing about equations is, so if I want to kill this one here in the denominator, I simply have to do this. So I'm going to multiply here with log there, and then the other side I also multiply by the same. So that is what we did here. Then this one multiplied by this one, you get this one. Then this one multiplied by this one, you get a 2. Then 5 multiplied by this one, you get this. Simple. So you're going to have that. So when you reach here, okay, we can let, say, P or any letter of your choice equal to log xy. So that this one, we see it will become, where there is this, you replace with P, and there you're going to have 2p squared minus 5p plus 2. And then this will give you a 0. And then here you factorize, this is an equation, and factorize this one here, say 2p squared. 2 times 2 is 4. 1 and 4 are denominator factors of 4. So you have minus, say 4p minus p plus 2 being equal to 0. We're just factorizing, nothing new. Then you have 2p. You're going to have p minus 2. Then there you can have minus 1 to get p minus 2. That will be equal to 0. And then you are going to have p minus 2 and 2p minus 1 being equal to 0. So you have two values of p here, where p is equal to 2 and the other p is equal to 1 over 2. So don't forget that log y to the base x is equal to p. So let us find the value of this log xy when p is 2. So you see that this is log xy being equal to that value of p there. And how do you express this one in exponential form? So in exponential form, this one will become y being equal to x squared. So let's say that is your expression 1. Then you also have that log xy is equal to the other value, which is 1 over 2. Then this implies that y, so that implies that y is equal to x to the power 1 over 2, which is equal to the square root of x. But you know, this is what we've obtained from this expression here. So this is a simultaneous equation here. So we have that xy is equal to 64. And then we have that y is equal to x squared and y is equal to x, the root of x. So for the first one, y is equal to x squared, you consider xy is equal to 64. Let's bring xy being equal to 64. Then you have that your y, in the first case there, y is equal to x squared. So you have x times x squared being equal to 64. This is going to give you x to the power 3 being equal to 64. So you have x being equal to the cube root of 64. And what are you going to have there? You have x being equal to, what is the cube root of 64?
Isn't it not
So you
4?
find that, yes, you find the cube root of 64 there. So x is equal to 4. In that case. So what is the value of y when x is 4 in this case? So you can either use xy is equal to 64, or this one here, y is equal to x squared. But that is simple. Y is equal to x squared is simple. So you say, so you have y is equal to x squared. So whichever one you use, you get the same answer. So y is equal to x squared, which is equal to 16. So you have that when x is equal to 4, y is equal to 16. And the other expression, you can obtain it from so you have that xy is equal to 6, 4. And from the other expression, you observed to say y is equal to the root of x. So using this one here, you're going to have x by this one, the y, the root of x being equal to 6, 4. So this is x by x to the power 1 over 2 being equal to 64. Similar basis, what do you do to the exponents? You add, this is 6 to the power, what is 1 over 2 plus 1? You get 3 over 2 being equal to 64. What does this imply? So this implies that so you can multiply this here, 2 over 3 and 2 over 3. Then you get your x being equal to the cube root of 64 squared. And you're getting 4 squared, which will give you 16. And then what is the value of y when x is 16? So you have y is equal to the root of x. X is 16, y is equal to square root of 16, y is equal to 4. So you see, so they've just interchanged, which makes sense because so we have that when x is equal to this value here, which one? This value 16. So let's say when x is equal to 16, y is equal to 4. And the other one, when x is equal to 4, y is equal to 16. So those are the values of x and y. And you rest your case there.
Oh, excuse me, sir.
Huh?
Can you show the first page where is the question?
What is the question? This one?
Yes, sir. Yes, sir. Now they are making the nine. Oh my God. Oh, okay.
Where?
I wanted to check where you were making making x and
Changing
y to be
the,
the same. Yes, the basis.
or changing the basis here?
Yes.
Oh,
Like
okay.
since we have different from this equation, we have log 2 base x and also log 2 base y. Can you explain how you change here in this part?
I explain here
Yes, sir.
how we change here. Okay,
Yes,
so
sir.
there are some rules of so there are laws of logarithms, guys. So I'm sure you know this. So this is the rule we're using we use them in simplifying. So we have the first one here, which says, oh, it's already 30 minutes. We're supposed to meet for 30 minutes. So we have the first rule, the one we've been using. So when you have something, an expression of in such form, then that n can be multiplied by this. So you just bring the n there and multiply it there. Then this is what you're asking now. So just take note of this. Whenever you have log nx, say log x to the base n, and you want to change it to any base, it's any base. So you want to change this logarithm to any base. So you do this. So you introduce the new base, say b here, then you maintain the x there. Then you divide that by, say, log, you maintain the base, then the n comes there. So that means you've changed the base from n to base b. That's how you change the base. It's simply the change of base. So you can change, say, log 4, 3. So you can change this one to n base. And how do you change that one? Say if you want to change it to base 5, so that will be log, you introduce the new base 5, then 3, then over log 5, you maintain, then you bring the 4 there. So you've changed the base from 4 to base 5. So this is what we did here. So I noticed I wanted to make my work easier because I know if I work around with the laws of logarithms, I'm going to be able to solve this. I know when I have the same bases, I'm going to apply this here and get that there. So you have a log xy, and then I can come up with a some form of a quadratic equation, and then solve for my desired results. So, that's how you